So I want to talk about functions. Recall that the definition of a function is that you have one output for every input. So I might have talked about a soda machine. When you go to a soda machine and you put in your money and you press a button, when you press the button for Dr. Pepper, you expect to get a Dr. Pepper. If you get a Sprite, then the machine is not functioning. So you might have more than one button for a Dr. Pepper, but each of those Dr. Pepper buttons should correspond with a Dr. Pepper. If it does not, if you press a Dr. Pepper button and it's possible that a Coke or a Sprite can come out, then that machine is not functioning. It's not a function. So keep that in mind. There are different ways to express functions. So in mathematics, you might see a set of points. Make sure that each x value corresponds to one y value. There aren't two y values possible. You might also see functions expressed as equations. So here, f of x is equal to x squared plus 3x plus 2. Now, it's not important that that's called f of x. This variable may change. F is simply the name of the function here. It's understood to be the name of the function, but that could be g or s or any other English or Greek letter. So f of x, x here is denoting my independent variable, by the way. And this f of x, some teachers might have told you to just think of f of x as the same as y. These two equations are they're saying the exact same thing. Y equals, in this case, this would be my dependent variable. So this notation we might change quite often and just be comfortable with that. These are really saying the exact same thing. Both of these equations are functions. You'll notice that the dependent variable is linear, so it is to the first degree, and that identifies that this is a function. So for x values, when I plug in x values, I will get only one particular y value that matches up with every x value. And maybe the y value repeats, but any x value identifies with only one y value as the output. So keep that in mind. A graph, remember, is the set of all the points that solve an equation. So if I actually graph this parabola is the set of all points, and I know that that's drawn by hand. You can graph that on a calculator, but this is the set of all points that solve those equations. You'll notice when I graph that, the graph is a function. You might recall the vertical line test. When I hold my pen vertically parallel to the y-axis, and I might move my pen left to right, slide it left to right gently, my pen will only touch that parabola in one place. That is telling me that for every x value that goes into this equation, there is only one outcome, one y value. So the vertical line test is useful to test if a graph is a function. So an equation, you might look at the degree of the dependent variable. For a graph, you might use the vertical line test to determine if you have a function. And you're going to practice this in identifying functions to understand this a little bit better. Before I end this video, I want to talk about a few other common function names. So keep in mind that we might work with g of t is equal to t squared minus 3 maybe e to the t, something like that. Now, that function, its name would be g. So this is just the name of the function. T here is the independent variable. So those are the input values. Variable. The domain here is all real numbers. Anything can go in for t. And the output here, the range, would be dependent on t squared minus 3e to the t. This is a combination of a quadratic and an exponential function, which we'll talk more about those. So this would be an example of a function. And a graph, you could use a graph to check the vertical line test, and that would help you identify that as well. Also, trigonometric functions, so we use these so frequently that instead of giving them a names like f or g, then we gave them actual names, and it is more than one letter, so sometimes that can be confusing. So sine, S-I-N-E, we use sin as an abbreviation, and then we throw a variable in. So I might have sine of x. So y equals sine of x. This is the name of the function. We don't ever write just sin. That wouldn't make any sense. That would be just a word that we would be trying to use as a variable. So sine is the name of the function. Sin is that abbreviation, and it denotes the function, the particular function that we use in trigonometry, because it's so common. So those famous functions, we give them names. So cosine, we don't ever write just cos. We write cosine, and that is the trig function that we will learn more about. Tangent. Some others that we'll talk about, logarithms. So we don't just use log, but log is an abbreviation for a particular function that we will work with. And I want you to already feel kind of comfortable with that graph. So we're going to talk about it. So I do want you to be able to recognize that graph and know its behavior. Log is a function, and natural log. We don't ever write just ln. So natural log, that is also a well-known function. So these are celebrity functions, and instead of giving them simple names like f of x or g of x, then we actually have given them kind of short words, abbreviations, and I want you to be able to recognize those comfortably.